Okay, so you survived example 1. Now we're going to talk about example 2. A little bit different question. They're giving us some information here. Now I look at this and it's kind of neat. I notice I've got a 43 degrees here, and I notice that I have an opposite angle theorem there. Do you remember that from grade 9? Opposite angles are equal, which means that this is going to be 43 degrees. And the reason is opposite angle theorem, often used as OAT. Now, take a look at this a little bit more. I notice that that's 90, that's 43. So this must be 180 degrees minus 90 minus 43. So 90 minus 43. Oops, sorry. 90 minus 43 is going to be 47. So this is going to be 47 degrees. And the reason for that is angle sum of a triangle theorem. ASTT. And we talked about that earlier in one of our videos. The same thing over here. I've got 90, I got 43. So this angle F is going to be equal to 180 minus the 90 minus the 43, which again is going to be the 47 degrees. Which is kind of interesting because if we take a look at this, I've got a 47 degrees here for angle F, and I got a 47 here for angle I. I've got a 90 and a 90 together, and I got a 43 and a 43, which means if I sit down and think about this, what I have, if I take a look at my angles, I notice that I have angle F is equal to angle I, and that's 47 degrees. I notice that I have angle G is equal to angle H, and that's 90 degrees in both of them. And I'm noticing that angle J, well, J is a hard angle to talk about because it's in both of them, but I could say angle FJG, or I can just call it angle J, and we'll know that I mean this side, equals angle J, and I mean this side. Angle J equals angle J, which is 43 degrees. So really what we have here is we have two triangles in which the interior angles are the same for each of them, correspondingly. Like they're not all the same, but 43 and 43, 90 and 90, and 47 and 47. When that happens, you get to say triangle. Now you got to name them properly. So FGJ. Triangle FGJ is similar to triangle, name it properly, has to be in the same order, IHJ. And that's a very powerful statement. And that statement comes from the fact that you showed that the three angles are all similar. And so you give some reason for that. You say angle, 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 similarity. Okay? And that's a reason for it. And what you did was you showed all the angles are correspondingly equal. So therefore, this is a very, very, very powerful statement. And this statement allows you to know something about the side length ratios. Because of this statement, you can now say the following. FG divided by IH must equal GJ over HJ equals FJ over IJ. Now notice I haven't done, I don't even know the question yet. I've just been playing around with math. What the heck is the question asking? Find the length of FG. There's F, that's FJ, no. FG, oh, they want this one. They want FG. Oh, okay, well, if they want FG divided by IH, which is 4.3, it's going to equal GJ. I don't know GJ, and I don't know HJ. So this one's no good to me. GJ and HJ don't help at all. FJ. Hey, FJ is 18.9. That's cool. And IJ. IJ is 6.3. Guess what? I have enough information to find FG. What I need to do is I need to bring this over here, and I say FG over 4.3 equals 18.9 over 6.3, because I don't care about the middle one. It's not going to help me. I don't need it. I notice the 4.3 is dividing FG, so the opposite of division by 4.3 is multiplication by 4.3. So it's FG equals 18.9 times 4.3 over 6.3. Using my calculator, 18.9 times 4.3 equals, divided by 6.3 equals 12.9. And I've answered the question. I know that FG, this point here, is going to be approximately 12.9. Do I have any units? I don't. And it said to the nearest tenth, and we have to remember tenth is 1 decimal place, and I did it to 1 decimal place. Isn't that a great question? All right, see you later.